Welcome all my friends and all my viewers. Today what we are going to learn is how to use the FIFOs in a C program, but using two FIFOs. So what we are going to understand how we can do the bidirectional communication using the two FIFOs. So let us first take the example that we have the two processes named as teacher and student. Now consider the process student. So student, what is going to do is first write the data to the FIFO 1 and that is received at the teacher side. After that the teacher write the data into the FIFO 2 and it is received at the student side. So for using these two FIFOs, we have the disk, and in the disk I have created the two files as FIFO 1 and FIFO 2. This FIFO 1 and FIFO 2 is only a reference to the data that is there in this FIFO, and this data in the FIFO is reside into the kernel. So this is the process page file descriptor table for both the student and the teacher processes. And as you all know that 0, 1 and 2 corresponds to the std in, std out and std err. So since we are going to do the read first and then write next into the teacher side, so we have this read file descriptor and write file descriptor at the 3 and the 4th. Same vice versa case. So we have this write file descriptor first and read file descriptor next. So first consider the case for the student. So first it is going to do is writing the data into the FIFO 1. So for better understanding, let us take the programmatic example. So what we are going to do is understand it. So see, in the student side we are not creating the FIFOs because it is to be created on the teacher side. First I will show you this code, then I will show you the teacher code example. Now consider this. So what we are going to do is opening the FIFO 1 as a write only mode, because we need to first write to the teacher, and opening the FIFO 2 into the read only mode because we are going to read after that. And this is error checking. Now if this FIFO 1 is success and FIFO 2 is failure, so we need to close or delete the FIFO 1. So what we are going to do is opening the file descriptor corresponding to the FIFO 1 and also deleting the FIFO 1 file that is going to do it here. So we are deleting the FIFO 1 file and closing the file descriptor corresponding to FIFO 1. Now after that what we are going to do is writing the data that is read by the teacher. So I am writing the data and taking the pointer to it. So this is the message that we are going to do. I show you this message we are going to do written into the teacher side. Now I am using the write system call. So write system call is used to write the data. So it's going to write to the data corresponding to this file descriptor, and the written data is this corresponding to this string, and this is the size of this data that is to be written. So what we are going to do is error checking in the case of the write. Now if the write system call fails, so we need to close all the file descriptors. So we have opened the two file descriptors corresponding to the FIFO 1 and FIFO 2. So we are going to close these file descriptors, and after that we are deleting the two FIFOs files that is created. After that we are going to return. So returning we are doing so as to not go onwards. Actually I forgot to mention it here, but you can write it if you want. Now consider the case for the teacher side. So in the teacher side what we are going to do is first creating the FIFO 1 and FIFO 2 file. Now we are using the two system calls mknode and mkFIFO. So mknode system call is used to create the two FIFOs. So empty node system call is used to create the FIFO1 into the in the read only and write only read write mode, because we need to read and write on the FIFO1. Now I am doing the error checking same, and after that what we are going to do is creating the FIFO2 file using same this read and write permissions, with the read and write permissions. Okay, now here I am specifying the 0 because I do not want to specify the major and the minor number, because I am not creating any of the special file, that is character or block file. So what we are going to do is first opening the FIFO1 in the read only, because at the teacher side first it is going to do is read. So if I show you this, so at the teacher side first we are going to read, and in the student side first we are going to write. So if I show you this, so I will first open the FIFO1 into the read only mode, and then I am checking the error, that if this open system call fails. Same case we are going to open the FIFO2 in the write only, and deleting the FIFO1 and closing the file descriptor. Now in the student side what we are going to do is read the data. In the teacher side what we are going to do is read the data. So for reading the data we are using the read system call, and the reading is to be done corresponding to this fd_read file descriptor, that corresponding to this FIFO1 file. So what we are going to do is reading the data, and after that this reading is to be done into the buffer side, and the size is specified as 1024. If you see this, now I am doing again error checking and closing the file descriptor. Okay, now I am writing the data that is to be read first using this write system call, and this one corresponding to the std out, that is my screen, and the data read is and byte_read. So I am doing the error checking and closing the file descriptor. So that task is done up to that. So what we are going to do up to the task is student first write the data to the file, after that it is received and it is displayed by the teacher. Now what we are going to do is write the data to the FIFO2 in the teacher side and reading it into the student side. So after this 2 seconds we are going to write the data into this message pointer, so message into this after the 2 seconds we are going to point the string, that is the message corresponding to this message string. Now after that I am using the write system call to write into this using this file descriptor and write the message and the string, and after that we are doing the error checking. So if on any of the error arises, we are closing the file descriptors and exiting out. Now you see that in the teacher side we are not deleting any of the FIFOs, because this is to be done on the student side only. So we are closing here if the error arises, and also if there is no error we are also closing it. After that we are doing the next line. Now if you see at the student side, what we are going to do is first reading it. So if I show you on the student side, what we are going to do is read the data using this read file descriptor. So using this fd_read file descriptor, so we are reading the data, and the data is to be written into this read into this buffer of the size. So we are going to do is first read the data and printing the error message and closing if the error arises. So you see that here we are going to delete the FIFO file if this read system call fails. Now what we are going to do is, whatever data we have read, it is going to be shown onto the screen. So using this write system call, we are again showing it at the std out or the screen and doing the error checking. Same case we are doing on the write system call and closing the file descriptor. Now if this file is properly work and any of the system call doesn't show any errors, so we need to delete the FIFO files so that it doesn't cause any of the problem. So what we are going to do is delete the FIFO file using this unlinked system call. So if this unlinked system call fails, again we are doing the error checking here. Okay, now and after that we are printing the next line. So for better understanding and in depth, what we are going to do is, let us see it working. So I will zoom it out for some. So my program name is teacher. So let us first run the teacher. Before that I am going to compile the program. So student. So let us first run the teacher side. So if I run the teacher side, it is going to be blocked. Why blocked? Because if I show you at the teacher side, it is going to be read first, and the main principle or the main concept of pipe is that it is going to be blocked the one side if the other side is closed. So here only the read system call is allowed and the other side is still closed, so it will block until the other side is opened. Now what I do is run this student program. So see this, now it is going to be show you that the message, so student message, that is going to be show, and after that 2 seconds, because I have wait for 2 seconds, this 2 seconds, after 2 seconds it is going to show you the teacher message, this teacher message. So main important thing is that the pipe is blocked, whatever end we are writing or reading, it is going to be blocked if the other end is not opened. So thank you for giving your precious time, and if you having any comments or any doubts, you can ask me. Thank you.